today. So last week at tutorial on Thursday, some of you guys and also some of your peers let me know that you guys have been working on relations and functions last week. So I wanted to do good notes on that for you guys to help you ready for your final exam. And so the first thing we want to do when we talk about relations and functions is give a good definition. So I want to start with a big old circle. And the title of this circle is relations. So I'm going to put it up at the top because I got to write stuff in here. And then within this blue circle, I'm going to put a smaller red circle. She's down here. And that little red circle is going to have the title functions. Okay. So here is the scoop. Relations is a big word. It's a big category with lots of things in it. And some of those things inside that big category of relations are functions. So that's our little red function circle. So a relation is a super general math idea. And it kind of goes like this. It says it's a matching or pairing of two things. So super specific, not at all. So we're matching up or we're pairing two things. Okay. And we have lots of options about what those things could be. So those things could be numbers. Let's be honest, we're math folks. It's often numbers. But it also could be letters. It could be words. It could be other stuff. Math people have a super general term for numbers, letters, and words. Things is not the word they use. They call it objects. The math word for things is objects. Okay. So we're matching and pairing. Now, functions are a super specific type of matching and pairing. And so that's how I'm going to start its definition. I'm going to say it's a special type of pairing. Uh-oh, I'm going to set a bubble. And the way it works is each input in the domain has only one output. And outputs are what we call the range. So a function is super special type of pairing, where each, oh, Eamon, will you click it off, hon?
It's not turning on.
There we go. Thanks, dear. It's all good. So functions are a special pairing where each input in the domain, that's a fancy math word, has only one output in the range. Now, you know from this math journey you've been on that math teachers, mathematicians, like to look at any math concept from lots of different ways. Okay. And before we've talked about 4 big ways that math people like to think about every concept. This will be all the way up through high school. So we like to think about these things graphically. That's kind of one big category. So that's why we do graphs. We like to think about numbers. That's a different perspective, a different way of looking at the math thing. We like to look at equations. And then we love words. That's why we give you guys word problems. I'm going to call the words category verbal. And just like we always do, we're going to look at functions and relations using graphs and numbers and equations and verbally with some word problems. So that's our goal for today. And I think the best way to do this is to just kind of work through some examples together. Now I'm going to pause for a second because I need a little feedback from you. Thumbs up if the pace is good, not too fast. Thumbs down if it's too fast. Thanks for the feedback. A couple of others. Okay. Okay. If at any point it gets to going too fast, you can shoot me a private message. So here's our examples. Our first examples, I guess we could call this A for the type. It's called mapping. And it's usually one of the first ways we talk about relations and functions. It's in the graph zone if you're keeping tabs. Graph up at graph-ish. And these guys look like this. We do like example 1. And then we usually kind of draw this oval shape, an ellipse. And next door we put another ellipse. Have you guys seen pictures like this? Maybe. And then what we do is we put some things in our left ellipse. That's the inputs or the domain. And I'm going to put letters in there, A, B, C, D. And we just kind of let them float. In my other bubble, you may have predicted, she's our output bubble or our range bubble. I think I'll put numbers in our range bubble floating about 1, 2, 3. So we've got our domain bubble, A, B, C, D. Our range bubble, 1, 2, 3. And here comes the relation part. We're going to start pairing or matching these up, and we usually use arrows. So I'm going to scoop up a purple arrow. I'm going to make my A match with my 1. So I'm going to draw a little arrow over from A to 1. That tells me my match. I'm going to let B go to 2. You can see I'm super creative, y'all. But C is also going to go to 2 because you can do things like that. And then I'll have D match up with 3. So there's sort of a graphish map of a relation. And the first question I have for us, this is like example 1, little a, is this relation function? So I'll give you a second if you want to try it by yourself and decide, is it a function? Is it not a function? And then, of course, I want you to explain how you know. So is it a function? And explain how you know. Okay. To answer this question, I'm looking at each of my inputs. So first, I'm going to put my eyeballs on A. And I say, does she go to exactly 1 output? And I'm happy. Look, she only goes to 1. We're good. Now let's look at B. B only matches 2. So far, so good. Samesies with C. She only matches 2. It's okay that B also matches 2. No bigs. And then D also goes to 3. I feel good. This is a function. And if I'm explaining to my teacher or explaining to my reader how I know, I can just say each input. So only 1 output. Okay. I got a question B for us. These kind of all go in triplets, you'll see. I want you to list and then math people often use the word elements of the domain or objects of the domain. I'm going to use the phrase elements. We're going to list the elements of the domain. Fun fact, when we play this game, we usually put those elements as a list with little curly brackets around them. So I make these crazy curly brackets. Usually when you're just starting to draw these curly brackets, they look crazy on your paper. Don't worry. They look crazy on my paper too when I started. So we're listing the elements of the domain. That's our game. You jot it on your paper. I'll jot it on mine. We'll see if we match. Oh yeah, that's it. My curly bracket was scooched over a little far, but that's okay. Excuse me, y'all. I'm going to highlight my domain in blue, and I'm going to highlight my domain word in blue. That's where I got those guys. Now I want you to predict the next question. Oops. Part C. You guessed it. List the domain. I mean the range, silly me. So I want you to list the range just like you listed the domain. Get your curly brackets going. There we go. 1, 2, 3. Well, now, fun fact, math folks are obsessive about being organized. And so if your domain or your range objects kind of have an order, like numbers have an order and letters have an order, then they ask you to put them in order. But if it's something weird like words, they don't really have an order. So that's how we do it. Okay, I want to take a peek at another one of these mappings. So in a second, I'm going to scooch to the next page. We'll call this one example 2. Ready to go? What's happening? Oh, there we go. Example 2 is another mapping. So I'm going to do my little whoop, my ellipses. And I'm not going to deviate much from before. Our inputs are also going to be A, B, C, D again. And our outputs are 1, 2, 3. We're going to map them a little differently. We're going to pair them differently this time. For this game, A is still matching to 1. Hyper creative. Then I'm going to do my matching for B. Boop. Boop. And then D, I'm going to have down here matching to 3. This mapping has a couple of quirks. Keep your eyes peeled for them, see what you find. I'm going to start out just as before. Is this relation a function? Once you've gotten it drawn, check out those inputs and outputs. Decide, is it a function? Okay, in the end, as I'm analyzing my inputs, I noticed that B, the input of B, has a mapping onto 1, but also a mapping onto 2. That totally messes it up. And as soon as you have one input that maps onto 2 things, then you've messed up your function. You can't be a function. Okay, just like before, I'm going to have us look at what the domain is for this thing. So B, this is the domain. Hint, it is not the same domain as last time. Plot twist. We're listing the domain. Plot twist. It's not the same as the last question. For this one, our domain just has three objects, three elements, A, B, and D. So we totally leave out C because she's not matched with anybody. She's floating in the input bubble, but because she doesn't have a pairing, we do not list her in the domain. She's just hanging out there. So we just list those three. Go ahead and list the range. Lickety split. Just so it's complete. This range does match 1, 2, 3. But if I had another number floating around that didn't have a pairing, we would not include it in our range. So that was one of our graph-ish ways to think about relations and functions. Next, I want to move on to a number-ish, a numerical way to think about these functions. One of which is ordered pairs. We're going to fill another thing in a minute next to this, but we'll come back to it. So ordered pairs is one of our numerical ways of thinking about this. And just like before, we're going to just barrel through this by example. This is our third example so far. And just like before, I'm going to tell you that we have a relation. So these ordered pairs form a relation. I'm going to list out my ordered pairs. -5 and 6. -5 and 6, and I got 4 and 3. -0 and -2. -5 and -4. I'm gonna run through those again. So -5 comma 6, that's 1. 4 comma 3. 0 comma -2. And -5, -4. Now, just like before, math people put these guys in curly brackets. So this group is called a set of ordered pairs. They also get their own curly bracket. It's just kind of keep things organized on our page. Now, the first question I have for you guys on this one is I want you to list out the domain. What is the domain? True to form, we got curly brackets. And I think I'm going to use my highlighter and go through and highlight my inputs the same color. It just helps me kind of see things. So we're listing our domain. That's the inputs. Some people also call these the x coordinates. They are. So those are my inputs, or the x coordinates. I don't make a little note. The domain is the x coordinates. And then I'm going to list those numbers. We won't list any repeats. So I noticed that number 5 is highlighted twice, but I'm only going to list her once. And I'm going to put her in numerical order. So these are going to go in number order. So -5 is the smallest. Next to smallest is 0. And the biggest is 4. So that is a nice, neat, organized list. It makes the math people happy. Paired with this domain question, you've predicted it. You may have even started working on it. What is the range? So let's do that next. I'm going to put my little hint to myself that the range is the y coordinates. Just like last time, I think I'll color code. Be sure to put these guys in number order. 2, 3, and 6. I had 4 in my range this time. I put them in number order. Makes the math people happy. Let's do my y coordinates. And for the trifecta, we shall now ask, does this, oh, I think I want to say it this way. Is this relation function? And explain for me. So is she a function? Explain yay or nay. So when I'm looking at these inputs, I got real squirrely about -5 because I noticed one time -5 paired with 6, another time -5 paired with -4. That's 2 outputs for that one input. So that's how I'm going to explain to my reader, because -5 input matches with 2 outputs. And you can list them there to really let your teacher know you're all over it. 6 and -4. Now for our next example, we're going to look at another numerical option. Okay, so we've done a graphy one, we've done ordered pairs, and I'm going to add its title up here next to my ordered pairs in that blank. It's tables. We are all the time having you guys look at tables, and I'm not going to lie, tables are frankly a little bit more organized way to list these ordered pairs. So you can see why it would come next on the list. So I'm going to scooch over, for example, 4, come along. And I'm going to draw us a little XY table. My at the top. Boop. And we'll have 4 sets of numbers in there. We can split that half and half again. So we get our table going. I'm super creative about my x coordinates. We're starting at 3, heading up. So 3, 4, 5, 6. Those are my x coordinates. Straight down the column. 3, 4, 5, 6 in my x column. And then in my y column, I got -2, -1, 0, and 1. Six, -2, -1, 0, 1. Part A question. Is it a function? Part B question. Main. Part C question, range. I'm getting lazy on my instructions. Function, domain, and range. Take a stab at those, see how they go. I got affirmative on the function situation. We definitely have a function. Each x value only matches to one y value from this joy. Go ahead and put down my domain so you can check it when you're ready. And this is my range. Put curly brackets around them. Put commas between the numbers. Okay, we got another table, quickie Mickey table. She's gonna look like the last one, so do your quick little XY table. We'll fill in a few numbers. Oh, no, I need to scooch mine down because I'm gonna add a little something under the example 4 table in a minute, so hold tight. Giving myself some space. So in my X column, I got a -2. I got a 6. -1 and a -2. And I got 7, 4, and -2 and 3. So my X column is -2. I'm going down. 6, -1 and -2. And my Y column is 7, 4, -2 and 3. And we're doing our same 3 questions because the way we're rolling. Is it a function? Explain. What's the domain? Range. Whoops. Is it a function? What's the domain? What's the range? I got a no-go on function here. I noticed that -2 matches with 7, but -2 also matches with 3. That is bad news bears in the function world. And that's what I'm going to explain to my reader. No, because -2 has 2 y values. 7 and 3. Now, I have something important to say. And the something important goes like this. Usually when I was teaching in my classroom, I would show these couple of examples and my students would say, well, it's obvious that it's the super simple way to figure out if something is a function or not. I just have to look and see if the X values get repeated. That's all I have to do. So as soon as I see an X value getting repeated, I know it's not a function. False. Because you could have a sneaky teacher, like Miss Poole was a sneaky teacher, and she might put a problem down like example 4, except here I'm going to add an extra box. Go to example 4. And what I used to do to check and make sure my students understood is I would repeat one of my inputs, like 3, but I would make her match to the same output, -2. She is still a function. Okay, so be careful. Don't just look for a repeated input because you could have a sneaky teacher like me. It only fails to be a function if the outputs don't match with the inputs. Okay, now the next bit of information on here is, as is the way, math people look at a table and they go, ooh, you know what I could do with that table? I could totally graph that table. So that's what's happening next. So our next sort of piece that we're looking at is graphs of functions and relations. And for this example, I want us to lean on example 5. And I want you to sketch a graph. It'll look like a scatter plot. So sketch a scatter plot of the points in example 5. Okay, so we're going to sketch a graph, do a little XY table, I mean my coordinate plane. We're going to plot those 4 points on our graph. 1, 2, 3. Oops, need more. I'm going to go ahead and label my points. That helps me stay organized with a little XY pair next to it. That point. Sketching our little graph, labeling our points, and we'll talk about it in a second. Take another minute or so to wrap up your graph. A little sketch. Okay, let's talk about this. Things we know. We know from example 5, this is not a function. And we could go through comparing the X and Y coordinates, but we also need to have a good and quicky-micky way to just look at a graph and tell whether it's a function or not. So this is sort of a new tool we're adding to our toolkit. And it goes something like this. We call it, move my face up there. No, I'll do the big reveal in a second. So what we do is we look for any points that are lying right on top of each other, in line with each other vertically. And so I got my eyeballs when I look at this on our friends, -2,7 and -2,3. If I draw a vertical line, vertical is an up and down, like a tree trunk line, like this, my vertical line that I randomly drew passes through 2 points, not just 1 point, but 2 points. And if that happens, then we do not have a function. So this test that we do is called the vertical line test. Did you talk about vertical line test? Did y'all use that phrase? Okay, good. I thought I had hope so. And a vertical line says like the test says something like this. If there is a vertical line that would pass through 2 points. In a relation. So if there is a vertical line that would pass through 2 points in a relation, then that relation is not not a function. So if you can find a vertical line that passes through 2 or more, could be more points, 2 or more points on a relation, that relation is not a function. We would say, the phrase we would use is we would say, this fails the vertical line test. That's often like an explanation we use. Maybe you could draw your vertical line and put dots so your teacher knows which spot you're looking at. But this guy totally fails the vertical line test. Okay. I have more questions for you in a second, but a couple of folks are still writing. Okay. I have 2 vocab words and I need to know if you use them in class, if you talked about them in this unit. They are discrete and continuous. Are those vocab words that y'all have focused on in class or not so much? Okay, I see lots of no's. Perfect. Then we do not have to take any notes on that part. So a discrete function, you don't have to write this down, but I'm just telling you because math is fun. A discrete function is bunches of dots scattered around. A continuous function is like when we connect dots. So that's what I got to show you next is some continuous functions. Here comes example 7. So for example 7, oh, we may have to add something to that. That's fine. We're going to sketch a graph. That's unacceptable. I try again. And we don't have to be super, super persnickety about all our thousands of tick marks on this one. But I am going to label a couple of points on this one. Okay. So I'm going to label a point back here. -2, 6. And then I'm going to go down to, excuse me, I'm going to go down to quadrant 4 down here and label this point for -3. And then my function is basically connect the dots. So it's like we're imagining every single dot between these 2 guys. We're too lazy to write all the dots, but there they are. I'm just imagining the dots. And we're going to write our trifecta of questions again. So first off, is this a function? Explain how you know. Is this a function? Explain how you know. I'm happy to report she is a function. If I imagine every single possible vertical line I could ever draw, can't even draw them all. None of them cross my blue curve, my blue line twice. So I can say with confidence, she passes the vertical line test. And I think I'll use that for my justification. Yes, because it passes the vertical line test. So in my classroom, that was a good justification for me because I knew my students knew the vertical line test. But you should pay attention to how your teacher answers this, because they might ask you to do a slightly different explanation. Like they might ask you to say each input only has one output or something like that. So just watch, because all of us math teachers are a little different. Now, the next thing I want to talk about is, I should have put it before example 7. I kind of failed us. So we're going to put a little like sticky note right here of information. Because domain and range gets a little different when we start having continuous functions. We usually write it differently. And so that's what we want to take a little note about. Range. So here's our little sticky note. Okay. Now, just like before, domain is all about the x values. It always is. But when we're talking about continuous functions like lines and stuff, we kind of have the highest. Okay. So it's not going to be a list of numbers with curly brackets. It's just going to be a report of the lowest and the highest. And then the math people assume everything in between. Notorious laziness. Range is samesies, except this time with the y value. So the range is the lowest y value. The highest y value. So we list the lowest, we list the highest. The math people assume everything else in between, so we don't have to write it. And then we have some special symbols that we're using. And this is where I'll have questions for you guys, because I don't exactly know what we're doing in class. So one set of symbols are inequality symbols, where we might have less than, greater than, less than or equal to, or greater than or equal to. Do you guys use those symbols when you talk about domain in class? You've been using those? Maybe? No? I got a no. I got a lot of blank faces. Ay. Okay. Another set of symbols, show you, is parentheses and corner brackets. Have you been using any of those symbols? Affirmative on those? Okay. So I have a question. Should I only use these green ones when we answer our questions? Is that consistent with what you've been doing in class? Okay, I got mixed reviews on it, so I'll do both of them. Okay. Oh, not my intent. Go back. Okay. So we're gonna write each answer both ways, and then you'll be prepared for when your teachers throw it at you. So I'm going to start with part B. We're going to ask about the domain. What is the domain? And I'm getting my highlighter out to keep me organized. I know that the domain is always x values, so I'm going to highlight my x values at the edges. So my lowest x value and my highest x value. And I'm going to start with inequality style. What did I do? Green and red. Okay. So this is inequality style. We want to tell our reader that x is between -2 and 4. And the way that math people say x is between, it's like a standard phrase. They put an x in the middle, and then they put inequality symbols, and they're always going to have the small side on the left and the big side on the right. So that literally in math translates to x is between. X is between, and then we just have to list our lowest x value on the left and our highest x value on the right. So -2 is hanging out over here. 4 is hanging out over there. There's a little bit more we have to do, y'all. I'm not quite done. Okay. So in the past, I want you to watch this next part, but you don't have to write this next part. So in the past, I think you guys have like graphed like X is greater than or equal to 4, and you put like a number line and 4, and then like a little closed circle, and then shaded that way. Remember this from like 6th grade and probably 7th grade. My grid went away. That's irksome. Hold on. Come back. Oop. There's my 4. There's my shading. And then we shade this way. Okay. And then if I took away the equal sign, then instead of a closed dot right there, we had a big old open circle. Okay. We're going to have the same situation with these graphs. So I noticed that I have closed circles right here at the edges of my line. So I need to have an equal sign under those inequality symbols. And that tells my reader, yep, you got a closed dot on that end. The left end, you got a closed dot on the right end. That's okay. Now, I want to show you how math people would write this exact same answer, but using the different style. So we call this one, usually they call it interval notation. It's the green way. Lots of math people love interval notation because this whole X's between part, they don't put there. They just put a comma. And then on the left, you'll put the very lowest X value. And on the right, you'll put the highest X value. So there they sit. You can see why lazy mathematicians like this one. Okay. But we still have to communicate to our reader, to our whoever's looking at our work, that we know we have a closed dot on the left-hand side. And the way that we do that is by using a corner bracket. So that says, I know I got a closed dot on the left. And for this graph, it's same as on the right. I got a closed dot on the right. So I'm going to put a corner bracket. And I'm going to go up to my post-it note of info and I'm going to put closed dot. And then under the soft ones with no equal sign, I'm going to put open dot. So we got closed dot. We got open dot. You'll eventually have to be flexible with all these different types of notations because they put, nobody has preference. They do it lots of different ways. So next on the list, I want you guys to tackle range on your own. And I want you to do it both styles. So now I want you to write the range. And I want you to write it inequality style. And then I also want you to write it interval style. So take a second to do that. So many problems I want to do. We don't have time for them all. It's tragic. So you're listing out the range. Ooh, for inequality games on range, we don't put an X in the middle, we put a Y. I didn't tell you that for the game. So Y is between, looks like that. Double check that you put your lowest Y value first on the left and your highest Y value on the right, even though it kind of feels flip-flop of the picture. They always want the lowest on the left and the highest on the right. And then for interval notation, plot my -3 and my 6 down. Put those corner brackets to tell my reader I have closed circles and call it a day. Okay. I want to sneak in. Yeah, we have to. I want to sneak another graph in real quick. An equation and then a verbal. We'll see. We'll see how far we can get, guys. Okay. Example 8. She's coming up. Okay, we're gonna sketch another graph. So draw yourself a little XY axis. Nothing fancy. We don't need tick marks. Oh, that's false. We do need a couple tick marks, but only a couple. Boop, boop. I'm gonna go out to 2 on the x-axis, 2 on the y-axis, and then I'm gonna go up 1 and down 1. And we're going to draw an ellipse. It's a fancy math word. It kind of looks like an oval. And my ellipse is going to go through the regular 2 and the -2 on the x-axis. That's going to go through the 1 and -1. And I'm going to draw it as best I can, but it's undoubtedly going to look cattywampus and silly. Yours probably will too. For the use, we shall ask our 3 questions. Is this a function? Explain how you know. What's the domain? And you get to choose your preferred method of writing the domain. So you can choose the red inequality or the green interval notation, your choice. And I want you to list the range. Again, you can choose your own adventure of which symbols you want to do. I'm going to start filling in answers. You can check as you go. Oops. I got a no-go on the function situation because I have a spot. In fact, I have many spots where it does not pass the vertical line test. I drew one, so my teacher would know that I knew. For my domain, I remember domain is x's, so on my inequality style, I plopped an x in between those 2 guys. My low value was -2, my high was 2. And then for interval notation, I got my -2 and 2 with corner brackets around it. And then for range, I noticed my low value on my range is -1. My high value is 1. If you're into the green interval style, she looks like that. Now, y'all, I did actually put closed dots there. They may not have put closed dots. They may have just have drawn the curve going through that, and that's okay. We still would have put these corner brackets and equal signs under there. So they don't have to put a dot dot. It just has to go through that point. Okay. I want to sneak in at least one more. Okay, because we haven't done any equation styles. So this one is like example 9. So sometimes we math folks hand y'all an equation. So let g of x equal 3x plus 12. So I'm going to hand you an equation that represents a relation. Well, 3x plus 12. And then I'm going to tell you what the domain is. So the domain of g of x is curly bracket 0, 1, 5, and 6. So I'm going to tell you the domain. 0, 1, 5, and 7. And I'm going to ask you to please find the range. For the outputs. So I have 0, 1, 5, and 7. I want the range. That just means we substitute. Because I remember that domain is code for x values. So I just got to take each of those x values and substitute them in. Another color. No. Yeah, that's fine. Well, y'all check my math on this one. I'm doing this on the fly. Let me know if we have any mismatches. So math people love this because they're sneaking in 4 substitution problems in one. When we list the range, all we have to do is tell the reader, tell our teacher, those output values, those 4 output values, they do want us to list them in order, which these guys kind of happen to be in 12, 15, 27, and 33. 12, 15, 27, and 33. Another question we might ask, is this a function? Things like that. Make a table, make a scatter plot. Okay, have you loop through all this stuff? I have one final question. It has to do with a gumball machine. So we have one last thing to do. Here we're scooching. This is example 10. Come on. Do you guys know what a gumball machine is? Have you seen these things before with the big globe and a stand? And you put change in there? Yes, we've seen this. No, we haven't seen this. Okay, I never know when like my examples go out of date because sometimes I say things and my students look like me. I've gone crazy. Okay, so hold on. You don't have to draw the gumball machine unless you still feel so inclined. So when I was a kid, many moons ago, my best friend's family had a gumball machine in their hallway, which I thought was the most amazing thing ever. I have no idea why they had that. So the scoop on this gumball machine is that Howard Middle School has put a giant gumball machine in the cafeteria, and they have filled it, as you would expect, with golden and navy blue gumballs. So there they sit, blue and gold. And this gumball machine offers gumballs at the bargain price of 25 cents. So if you have a quarter, you get a gumball. So I'm drawing my 25-cent piece. And I'm imagining that 25-cent piece as being my input. So in she goes to the machine. Any guesses on the output? Here, right out here, out of the chute. The output is first incorrectly spelled. Is the gumball, but we're going to pay attention to the color of the gumball. So the input is my quarter. The output we record is the color of the gumball. And as we sign off, I have 3 questions for you. Is this a function? What is the domain? And what is the range? And the domain and range we'll list with our usual curly brackets. So is it a function? What is the domain? And what is the range? This is one of those verbal word examples for those you guys keeping track. Okay, let's take a gander. My input, my domain. I only have one input. It's the 25-cent piece. Boop. So my input is my quarter. My output is the color of the gumball. It could be blue, or it could be gold. I have two outputs. Okay, thumbs up, she's a function. Thumbs down, she's not a function. Verdict? Yeah, yep, totally not a function. Because the input of a quarter, oh, it's fun, could have either of the outputs, gold or blue. That was a whole lot. Y'all did great today for